Understanding AI agents. Before we define AI agents, it's important to look at a major shift happening in the field of generative AI, the move from monolithic models to compound AI systems. From monolithic models to compound AI systems. First of all, single models have their limitations. Models are limited by the data they were trained on. They cannot access personal or external information by themselves. They are costly and slow to adapt. Fine-tuning requires large datasets and compute. For example, if I ask, how many vacation days do I have left this year? A standalone model will likely give an incorrect answer. It has no knowledge of my personal vacation policy or access to HR databases. Secondly, compound AI systems have their benefits. Compound AI systems overcome these limitations by combining models with other components such as databases, APIs, and logic flows. As the vacation example, compound system, the user asks about vacation days. The system passes the query to the model. The model generates a search query to check the HR database. Database returns the correct number of vacation days. The model converts this into a natural language response. Christine, you have 10 vacation days left. This is a compound AI system, a modular setup where the model is part of a larger process. Let's talk about principles of compound AI systems. Number 1, modular components. A compound AI system can include models, programmatic logic, databases and APIs, and tools. Number 2, control logic. Defines the path a query takes through the system. Example, a vacation policy system is programmed to always check the HR database. Limitation, if you ask about the weather, the system fails because its logic doesn't support that path. This is where AI agents enter the picture. So what are agents? An AI agent is a system where a large language model, LLM, is not just a component but is placed in charge of the control logic. Instead of following a rigid path, the agent reasons, plans, and decides which tools or actions to use. This is made possible by recent improvements in LLM reasoning capabilities. Think of it as moving from programmed approach, think fast, follow fixed instructions, to agentic approach, think slow, make a plan, adapt, and adjust if needed. What are the core capabilities of AI agents? They are reasoning, action, and memory. Let's learn one by one. Reasoning. The LLM can break down complex problems and design step-by-step plans. Action. Agents can call external tools like APIs, calculators, search engines, other models. Example tools can be web search, database lookup, math calculation, and translation model. Memory. Agents can recall Number 1, previous user interactions, conversation history. Number 2, their own reasoning logs, thinking out loud, steps. Number 3, this allows for more personalized and contextual responses. Let's move to configure agents. One common approach is react, reason plus act. How it works, step 1, use a query sent to LLM. Step 2, LLM is instructed. Don't rush, plan your work, use tools when needed. Step 3, the model reasons about the problem. Step 4, if required, it calls external tools. Step 5, it observes tool outputs, adjusts if necessary, and iterates until it reaches a final answer. Let's revisit the vacation and sunscreen planning example. User query. I'm going to Florida for 7 vacation days. I'll be outdoors a lot and I burn easily. How many 2-ounce bottles of sunscreen should I bring? Steps an agent might take are 1. Retrieve vacation length from memory or HR database. 2. Check the weather forecast, hours of sun expected. 3. Look up health guidelines, recommended sunscreen dosage per hour. 4. Perform math to calculate bottles needed. This demonstrates how agents can orchestrate multiple steps, tools, and reasoning paths, something a simple model or rigid compound system cannot do. Let's figure out which is the right approach for different systems. Programmatic systems, best for narrow, well-defined tasks because it's more efficient, predictable, and consistent. For example, always checking vacation days in a database. Agentic systems, best for complex, open-ended, or unpredictable tasks, for it can reason, adapt, and handle diverse queries. For example, solving GitHub issues, handling customer support, or planning complex projects. Looking ahead, compound AI systems are here to stay. They are becoming increasingly agentic, with LLMs controlling logic and decisions. Future systems will balance efficiency, i.e. programmatic paths for narrow tasks, and flexibility, i.e. agentic reasoning for complex tasks. Humans will remain in the loop as accuracy and reliability continue to improve. Now you have a clean, structured understanding of AI agents, moving from the evolution of compound systems to the rise of agentic AI.